Okay, well, it's 10 o'clock, so we can go ahead and get started. Thank you all for joining another edition of the Long Coffee Break. My name is Bill Rowan, and I'm a senior sales engineer with Long. And today we are going to be talking about the Condair DL series Adiabatic Humidifier. We are lucky enough to be joined by Marlee Spiegelberg, Applications Engineering Manager with Condair. Thanks, Marlee. With that, I'll hand it over to you.
Yeah, thanks, Bill. Thanks again so much for having me today to talk about the Condair DL. It's a very unique product that I'm always excited to talk about. So let's jump right in. Just a quick agenda for today. We'll start with an overview of what is adiabatic humidification, then compare 3 adiabatic technologies. After that, we'll jump into the DL series and cover some features and benefits, as well as applications. And then we'll finish with a slide on some key takeaways. So first off, what is adiabatic humidification? For humidification, water needs to change state from liquid to vapor. This uses about 1,000 BTUs of energy. Steam humidifiers add energy via an energy source of some type to the water to boil it. It could be gas, natural gas, propane, electric, or steam, such as live steam. But with adiabatic humidification, water takes the energy from the surrounding air to make that phase change happen. This can happen either by atomization or evaporation of water. And along with this humidification, you also get a cooling effect because when water evaporates, again, it pulls that energy from the air, which we sense as a change in thermal energy or temperature. Some atomization humidification technologies are most commonly high pressure nozzles, which you may be familiar with, and ultrasonic units, which are very common for at-home or residential humidification. And then with evaporative technologies, we have evaporative media, generally fiberglass. And then a mix of two, we have this hybrid technology, which is what I'm going to get into today. So what are the benefits of adiabatic humidification? The main one here is energy savings. So where steam humidifiers use that electricity or gas energy, adiabatic humidifiers, again, draw the energy from the air. So the cost of the energy could be cents on the dollars here to power your humidifier. If you look at the site chart on the right, you can see the two processes as well. With isothermal humidification, temperature is more or less constant. With adiabatic humidification, you're cooling down that surrounding air due to the constant enthalpy process. And with this, you get that free cooling benefit. Adiabatic humidifiers are also very flexible and scalable. They have very custom setups. You can allow for redundancy. They also have very large single system capacities up to 2,200 pounds per hour. And because a lot of them need water treatment, they end up being very low maintenance systems compared to steam units that boil water, leave minerals behind, and have scale that you need to clean. If we take, for example, this hospital application that requires around 2,200 pounds per hour of humidification, with this high load, you could end up using 10 resistive element or electrode units versus a single adiabatic system. So if you can take advantage of the beneficial evaporative cooling, your energy cost could be almost 250 times less or less than 1% of an electrical isothermal load and energy cost. So next we'll compare these adiabatic technologies we just talked about, the evaporative versus atomizing versus that hybrid system that I mentioned. So common in-duct adiabatic technologies we see in the market are evaporative media and high pressure. Evaporative media that Condair offers are the ME and the MC series. We also have the HP series high pressure system. And then we have that DL hybrid system, which is a combination of low pressure nozzles and evaporative media. Just an overview of the evaporative and atomizing systems. For an evaporative unit, water is pumped to the top of a media pad and flows down with gravity. It collects in a tank and is recirculated. And as air flows across the media, water pulls energy from that warm, dry incoming air to evaporate. Water is then absorbed into the airstream, which is cooled and humidified. Evaporative humidifiers are very efficient adiabatic coolers, are generally used in these types of applications.
Good morning, Christine. How are you?
Hi, pressure systems, atomization HP
No
series.
complaints.
Sorry. High pressure systems, HP series, the water is treated with a reverse osmosis and distributed into the duct using high pressure nozzles. And similarly to the evaporative system, the water is then absorbed into the airstream, which is cooled and humidified. High pressure systems generally have a very high control accuracy because of the setup. And next, we have that dual humidifier technology. So the DL series offered by Condair combines both atomization and evaporation technologies with low pressure nozzles and a porous ceramic media. This is why we call it the dual system, because it has both. And the DL features the advantages of both these technologies while solving the challenges that these technologies generally face on their own, which is mainly installation length and controllability. So let's do a quick overview of the DL series, and we'll get into the features and benefits and applications. So just a product overview. This is a general DL installation. So first we have our filter. This is a pre-treatment for the water treatment that's required. Next, we'll go into like a backflow valve. After that, we'll soften. This is a pre-treatment to the RO system. It helps extend the life of the membranes. There we have the required reverse osmosis system. So the DL does require reverse osmosis water treatment and does actually need pretty low conductivity values of about 15 microsiemens per centimeter. After that, we go into the hydraulic unit, which has our Hygiene Plus system. So this is a patented silver ion dosing system of the water supply. And from there, we go into the VFD booster pump, into our low pressure nozzle grid, which sprays the water into the air, which then lands on our ceramic media. So the DL really improved on the existing high pressure technologies. High pressure systems have been around for years. Aside from using higher quality components and better pump technologies, it's a fairly similar system across manufacturers. To solve the design limitations that come along with high pressure systems and to improve on the existing technology, we added in that evaporative component to get this DL series. In doing so, the installation length is significantly reduced. It's very energy efficient due to the reduced nozzle pressure. Water efficiency is also increased because any water that would typically go to drain on a high pressure system is then captured by that ceramic media at the end. The DL is also very hygienic. It has that silver ion dosing, as I mentioned, and the DL is low maintenance due to its ceramic media and VFD pump that don't need any maintenance or replacement. The DL features these improvements, but it also offers that same high control accuracy of a high pressure system, which is plus or minus 2% accuracy. So some features and benefits of the system. First, that silver ion dosing is carried through hoses, through nozzles, onto plates, inactivating any bacteria it encounters. Silver ions are widely used in industries that require the most sterile environments, and it's even used by NASA. On top of this, the DL has the Fresenius Institute certification. Fresenius Institute is an independent certification institute that provides comprehensive hygiene testing and certification for manufacturing equipment typically used in hospitals or other applications requiring a high level of hygiene. So to do this, they installed and ran the DL for months. They tested samples from the airstream, water, and ceramics to ensure hygiene and then provided the certification. There are also different built-in hygiene functions to make sure the system stays free of bacteria. There's no recirculation of water in the system. We have conductivity measurements and high alarms if conductivity goes over a certain amount, and drain and flush sequences that are automated. The DL type A system, which is our standard system, also has a VFD booster pump. This pump improves modulation by boosting the supply pressure to the ideal operating pressure of about 7 bar. This allows for fine control up to that 2%. And then our nozzle grid, so we have nozzles installed on a flexible clip, and they can be angled at about 15 degrees in any direction, which allows for full coverage of the ceramic media after. They're 316 stainless steel and extremely hygienic. They're also operate again at low pressure, so there's less energy used here as well as wear. The operating pressure and nozzle openings ensure optimal droplet size, increasing the efficiency of the ceramic stage and ensures no water carryover past that ceramic either. And then finally, our ceramic plates. This is a patented design and is a Condair exclusive. It significantly reduces the water waste by evaporating water not absorbed by that nozzle section, creating a water efficiency over 90%. The ceramics also remain dry, meaning very hygienic operation. And that media is very porous, helping with the pressure drop. So at about 500 feet per minute in a duct, you could get 0.2-inch water column pressure drop from that media, which means low energy draw from the supply fans. The ceramic media also has no need for replacement, unlike a general evaporative media that's fiberglass or polyester. So it's extremely low maintenance for this reason. This slide really shows the primary benefit of the DL system, which is that short installation length. So we see here the DL can be installed in a 24-inch or 2-foot section with 20 inches before or after a heating coil, with about 4-inch after the media for any carryover or service access. If you compare that to a typical evaporative system, which could be a width about 20 to 30 inches. If you have that proper service access after and the proper 2 feet before, it's an increased installation length. And then depending on airflow and humidification loads and your air temperature, if you look at a high pressure system, you could have an installation length of about 60 to 96 inches or 5 to 8 feet to get that same absorption efficiency that you would with a DL. So definitely a large advantage with the DLs, having that really small installation section, which is good for new builds, but also good for retrofits where you might have a really tight installation. And for applications, of course, that high hygiene and controllability really lends itself towards like healthcare applications, pharmaceuticals, electronics manufacturing, and research laboratories. We've actually installed this equipment in over 80 healthcare applications in the US already. Applications with cooling requirements, where you can reduce mechanical cooling costs, can also be really beneficial. So those condos and office buildings, concert halls, museums, and libraries. And if cooling is not beneficial, you may have to consider preheating required to offset that cooling. And then finally, just a summary and some key takeaways. So some key takeaways of the DL series and adiabatic solutions. Adiabatic humidification provides energy efficient humidification and free cooling, which can reduce operational costs. There are, of course, different benefits associated with each technology. You have efficient operation, flexibility, hygiene. You can compare these benefits to the needs of the application to really determine which system is best suited for your job. For example, the ME series is very efficient, energy efficient cooler. So if you have that adiabatic cooling need, the ME series may be right for you. The HP is very efficient and precise and can do multiple AHUs. So if you have a big job, this could be a good application. And then the DL series with its really high hygiene standard and precision control is really good for those hospital or pharmaceutical jobs that you may have, as well as the condos, museums, anywhere where adiabatic cooling can be beneficial and they want precise control. Again, thank you so much for taking the time today. As Bill mentioned, a few of us will be in Denver next week, Sean, myself, and Sophia. So if you'd like to meet us or have us stop by your site, we would definitely be available. You can reach out to Long for any details on that. And thanks, Bill.
Thank you, Marlee. I really appreciate it. Thank you all for joining us on this coffee break. Please reach